I'm not with it today. I'm not with it today. What's my intro? Hello and welcome to... No, that's not it either. Right, hello, it's Plant Life Forever 69 and today I thought that we could talk about how a Venus flytrap actually works. Something that I don't see a lot of people talking about, so I thought we'd throw in some technical words that I don't actually use. I think they are good things to know, just for a base of knowledge about the plants that we all love keeping. So without further ado, let's jump into the video and I will talk a lot as usual. Okay, which flytrap shall I use as a demo? So the first thing that you need to know about carnivorous plants, all carnivorous plants, is why they evolved to be carnivorous. The reason for that is, in the wild where they grow naturally, they grow in really poor nutrient soil. So that means there's no minerals and nutrients that all plants need to survive in that soil for them to soak up. And if they did have that, then they wouldn't be carnivorous, because what they do is they supplement that nutrients that they're not getting from the soil by catching insects. So they trap the insect, digest it, suck all the nutrients out of the insect, and that's how they get the nutrients they need to survive. And that's why you can't plant them in normal houseplant soil or, anything like that. It has to be nutrient-free, mineral-free soil. Despite getting their nutrients from insects that they catch in the traps, they actually get most of their energy from sunlight. So they don't have to eat a lot. You can overfeed carnivorous plants. It's like over-fertilizing any plant. If you feed them too much, then you're essentially over-fertilizing the plant, and that's bad for any plant. So they don't actually need to eat that much. However, if they don't eat anything, then they will weaken over time, but it will take a long time for that to happen. There is only one species of Venus flytrap, but there are many different cultivars, and all that means is it's a one-of-a-kind plant. There's only one that you'll find in the wild growing in North and South Carolina, but there are lots of cultivars, and that just means that they've noticed mutations that occur naturally within the plant, and then they've bred that into a cultivar which basically produces that mutation over and over again. Similar to how you would breed a really red rose, where you take a rose that is super red and another rose that is super red, and you breed those together to get the reddest rose ever. That's how you get all of these different named cultivars. This is the DCXL, the biggest cultivar of Venus flytrap that you can find. The main thing that we're going to talk about is how these plants actually close and trap their prey. To begin with, I'm going to insert some pictures that I've made. I actually took a picture of, I think it might have even been this trap, just to show you all the different parts of the fly trap so we can talk about it. I'm probably not going to use the technical terms, because Isaac Newton once said, if you... Fuck, what did the smart man say? You don't understand something... No. Isaac Newton once said that if you can't explain something simply, then you don't understand it well enough. So I'm just going to stick to the simple terms, and I'm not a scientist and I don't know everything about these plants. Disclaimer, but I do know some things. So I'll insert the pictures now. I'll shut up and I'll put the pictures in, and you can have a look. So the traps are just modified leaves, so it's not a flower or anything fancy like that. It is fancy, but it's a modified leaf. So you have two parts to the leaf. You have the leaf base, which is all of these, the heart-shaped part of the leaf that the leaf blade, or the lamina, or the trap as I'm going to call it, comes off of that, and there's a petal running through the center of all of that. Each side of the trap is called a lobe, and each lobe has 3 little trigger hairs on it, and those trigger hairs are called trichomes. That's just a quick kind of overview of the anatomy of the trap itself. But I also wanted to talk about red pigmentation in the trap. Is it weird? Does it look like the Venus flytrap is talking, having it right in front of my face? So I wanted to talk about the red pigmentation that you see in the centre of the traps, because not all Venus flytraps get this. Some of them are bred to not have red pigmentation, so it's very characteristic of the type of Venus flytrap you have, the cultivar of Venus flytrap you have, but it is also correlated to light, and I'm going to talk about why. The red coloration, which I will put another little picture in here, it's called anthocyanin. I'm not sure if I pronounced that right, but anthocyanin, that is what this red coloration is called, the name of the pigment. And what that does is not only does it act as a kind of, it simulates the appearance of flesh, which obviously attracts carrion flies, which the plant will munch. It simulates the look of flesh, which is a common thing that carnivorous plants do. And non-carnivorous plants actually simulate flesh as well. The corpse flower, that does similar things to this. Not only does it look like flesh, so it attracts flies, but it also provides some protection from direct sunlight, kind of like a sunscreen for plants. And that has something to do with the way light filters through colours. That's beyond me, I don't know about that. It acts as a sunscreen for the plant, which is great for these because they do actually love direct sunlight. They love direct sunlight. If your trap has really red mouths, if the trap is really red on the inside, then you can be pretty sure that it can tolerate a lot of sunlight because it acts like a sunscreen. It's correlated to light as well because they say that the more light that you give a Venus flytrap, the more red the trap becomes. And the theory behind that is essentially that photosynthesis is done through chlorophyll, right? So the green colour, that's where the chlorophyll is, and it's the chlorophyll that does all the photosynthesis. Well, the anthocyanin, that doesn't have the same capabilities as chlorophyll does. It doesn't photosynthesize. So in order for the red coloration to develop, it will only develop if there's enough sunlight to keep the plant alive. Do you get what I'm saying? So if there wasn't enough sunlight, it would need more surface area to photosynthesize than it would if there was an excess of sunlight or just enough sunlight. So that's why the theory behind why they go red. So how does a Venus flytrap close? As you can see on the outside, we have these teeth, nice big teeth. You can see I can stroke them and it's not going to close. That's because these teeth, they just make a cage. They don't do any digesting or triggering, anything like that. On the inside, if I can get my camera to focus on them properly, or I might have to insert the picture again. There. Where those 3 red dots are, those are trigger hairs. Those are the trichomes, and that's what gets the Venus flytrap to close. An insect will crawl into the trap and touch one of the trigger hairs, and if it does that again on the same hair or a different hair, within 20 seconds, the trap will snap shut. Once a hair has been triggered twice or 2 hairs have been triggered within that 20 seconds, an electrical impulse is sent from one part of the leaf to the bottom part of the leaf, and that sort of like signals in your brain. That signals the trap to close. The traps are convex, they're sort of like in a V shape, and then as they close they concave. So in order for them to get that movement, they actually grow a little bit each time that they close and reopen. the mouth of the trap actually gets bigger. Once that initial closing has happened, the outer teeth, the cilia, I think that's how you pronounce it, the outer teeth, they create this cage. That is to let any small insects to escape so they don't waste energy on eating things that just aren't worth their time. So they're super clever like that. It also needs to have stimulation inside of the trap whilst it's closing for it to fully close. And what happens then, it will press the outside, the margin of the trap together really, really tightly so that it can't escape. And then it starts to secrete enzymes and digest the prey. And within a week, the trap will reopen and you'll be left with an empty shell of an insect that it devoured. They are incredible, incredible plants. The way that they reserve energy, they basically count. They have like a concept of more than one because that trigger hair has to be triggered twice within 20 seconds or more than one hair within 20 seconds. The way they don't waste energy on prey that's too small, phenomenal. So that is how Venus flytraps actually work. I'm so sorry if it was just a jumbled mess of me talking about random things. But yeah, soon the Venus flytraps are going to be in the fridge. So I'm making the most of them now while I've still got them as absolutely stunning as they are. Okay, well that's all for today, but thank you guys so much for watching the video, and leave a like or a comment down below and subscribe to Plant Life Forever 69. Okay, thanks, bye!